I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about the topic understanding model combination techniques in machine learning. We'll see one by one. The model combination schemes refers to strategies used to integrate multiple machine learning models in order to improve overall performance, generalization, and robustness. These schemes are especially useful in domains such as ensemble learning, multimodal systems, and hybrid AI. By combining these outputs of the outputs of different models, these approaches can leverage the strengths of each individual model while compensating for their weaknesses. As a result, model combination techniques help in achieving more accurate. So this is useful for this is useful for achieving more accurate, stable. In order to achieve this, we are using it. And reliable predictions, mainly reliable predictions compared to relying on single model. And we'll see the types. First, bagging. The another name of the bagging, we can call it as bootstrap aggregating. Bagging is an ensemble technique where multiple models are trained independently on different random subsets of original training data. Original training data. These subsets are generated using bootstrap sampling, which means sampling with a replacement. As a result, each model sees a slightly different version of the training data. After training, the final prediction is made by majority voting in classification tasks or by averaging the outputs in regression tasks. Bagging helps reduce overfitting. The main advantages of bagging is to reduce the overfitting and improves the stability of the model. A well-known example of this model is the random forest algorithm, which combines many decision trees. What it will do, it will combine the many decision trees using bagging. The bagging method is used in the random forest algorithm. Next, boosting. Boosting is a sequential model combination strategy where each new model is trained to correct errors made by previous models. Here, mistake in the sense what? Errors made by previous model. During training, more weight is given to data points that were misclassified earlier, allowing the model to focus on difficult cases. The final prediction is a weighted sum of all individual models' outputs. All weighted sum. So we can write it as WI, we have seen it now. The weighted sum of the. So here the weighted combination of all models. So here the final prediction weighted sum we can say it of. And boosting is known for reducing the bias and significantly increasing the model accuracy. Popular algorithms using this method include AdaBoost, gradient boosting, and XGBoost and Light GBM. The next algorithm is the stacking. Stacking means stacked generalization. Stacking is a powerful ensemble method that combines predictions from different types of models such as SVM, decision trees, and neural networks. These models are referred to as base learners and they are trained on the same data set. Their predictions are then used as inputs for final model known as the meta learner or meta model. This meta model learns how best to combine the base model's outputs. To ensure the meta model is trained effectively, cross validation is often used. And the stacking is especially effective when the base models are diverse in structure and behavior. Next type is voting. Voting is a straightforward ensemble technique where several methods are trained independently. So various methods we are going to train independently. Then what will happen means, and their predictions are combined to make the final decisions. There are two main types of voting. The first typing is the hard voting. The second type is the soft voting, where the more in the hard voting, where the most common class predictions are chosen, and soft voting, where the average predicted is used to determine the final output. This method is simple yet effective, especially when all participating models perform randomly well. Voting is commonly used in scenarios where model diversity enhances predictive performance without complex training dependencies. Next type is blending. So blending is similar to stacking. What's the difference is, but typically uses a simpler and more efficient process. Simpler and more efficient process. Instead of using cross validation to train the meta model, here what you are using is the holdout. Holdout set. A small portion of the training data is used to generate predictions from the base models. These predictions then serve as input for training the meta model. While blending is less computationally intensive than stacking, it carries a risk of overfitting if the holdout set is too small or unrepresentative. Blending is popular in machine learning competitions like Gaggle due to its simplicity and speed. Next type is cascading. The cascading involves arranging multiple models in a cascade, in the sense what it is a sequence. This we can call it as a cascade. Arranging multiple models in a sequence of layers or stages where the output of one model serves as the input for the. So here, if you are taking the output of this model will be input to this model. Output of this model will be input to the next model. This approach is often used to refine or filter predictions progressively. Each model or stage can be specialized to handle specific subtask or region of the data. Cascading is commonly seen in tasks like phase deduction, where early models eliminate obvious non-phase areas and later models perform more detailed recognition. A classic example is the Viola-Jones phase deduction framework. So this is one best example for this. Next, hybrid model. Hybrid model combines, what is the name? The name itself, we can say that integration of many models. Model refers different types of approaches such as machine learning algorithm with rule-based systems. This strategy is particularly useful when one method is better at handling edge cases or exceptions than another. Hybrid systems may also integrate deep learning with the traditional machine learning techniques. These models are widely used in real world applications like chatbot, mm, recommendation system, and fraudulent deductions, where combining knowledge based rules with the data driven insights lead to more effective outcomes. So, for instance, a hybrid model might use a rule based filtering with this is one different type of algorithm, this is one different. So, we are going to combine, we are going to integrate. So, the hybrid model might use the rule based filtering followed by the deep learning classifier. The name itself, we can say that. Next, mixture of experts. This we can call it as MOE. And the mixture of experts approach involves training multiple specialized models, each focusing on specific part of the input space or problem. A separate model known as a gating network, gating model, known as the gating network, is responsible for selecting which experts should be activated for a given input. This architecture is particularly useful for handling complex or large scale tasks by dividing the workload among multiple experts. And MOE improves the efficiency and interpretability by enabling dynamic selection of relevant models. It is commonly used in large scale deep learning systems where computational resources need to be managed intelligently. Next, ensemble selection. Ensemble selection is a process where a large pool of trained model is evaluated and only a subset that performs well together is chosen to form the final ensemble. The goal is to balance performance and model complexity by selecting models that complement each other, resulting in improved accuracy with fewer components. This approach is often automated and is widely used in AutoML. So we can call it as automated machine learning. Shortly, we are calling it as AutoML system to find the best performing combination of models without manual tuning. So in this case, without manual tuning, without that is why we are calling it as auto manual. Without manual tuning, we are going to use it, and this ensemble selection can lead to robust models while minimizing the redundancy. So hope everyone enjoyed about this topic. What is the topic we have seen? It is very interesting. Model combination schemes. The remaining things we'll discuss in the next lecture. Thank you.